In this section, we're going to be going over what they're calling large prime numbers, and we're really going to be focused on one thing that's found in your book on page 193. It's section 5.2 if you go through the ebook. And here's what it says. It's called the Mersenne numbers and Mersenne primes. And here's what it says. It says that for n being a natural numbers are accounting numbers, 1, 2, 3, etc., right? As high as you want to go. The Mersenne numbers are m sub n being equal to 2 to the n minus, apologize, not like that. Let me clear that minus and where it is. 2 to the n, and then a big difference here, minus 1. That's a Mersenne number. And so Mersenne was a mathematician, and he was after finding primes, and he came up with these numbers. And here's what he noticed. Number one, if n is composite, then so is, and I guess I'll write it like this, then m sub n is composite. So let's watch that in action. Let's pick a composite number. It has to be a counting number, but let's pick something like 4. Okay, so 4 is definitely a composite number. 2 times 2 is its makeup. Let's look at the Mersenne number 4, right? And so that's going to take 2 to the 4th minus 1. Well, 2 to the 4th is 16 minus 1 is 15. And yes, 15 is composite. So what they're trying to say is, hey, if you start out with the composite number as your n choice, then 2 to that composite number minus 1 will also always be composite, right? And so, great, we understand that potentially. And a lot of the homework is finding these numbers, right? And just plugging it in. You'll have a calculator, so things will go really well, I'm hoping. The second thing that it says is if n is prime, then m sub n is, unfortunately, either prime or composite. We're not sure which. So it does spit out prime numbers again, but it also spits out some composites. The prime values m sub n are called Mersenne prime. So if it comes out to be a prime, then it's a Mersenne prime. And large prime numbers being verified are currently large prime numbers that are being investigated are currently Mersenne primes, is what it says. Now, you may think, well, why do people care about large prime numbers? It's actually the way that the whole internet encryption works. They grab two super huge prime numbers, multiply them together for a super huge composite number, and they're able to do the encryption where, unless you know what those two really big prime numbers are, you'll never be able to decode it. And there's no formula for generating prime numbers, and so it's very difficult. And so they're special. Let's look at the first few Mersenne numbers. So let's look at m sub 2, right? 2 squared minus 1. Easy, that's 5. Now, that one's prime. We started out with a prime choice, n equals 2, and we ended up with the prime number 5. What if we chose n equals 3 and looked at m sub 3? Well, that's 2 to the 3rd minus 1. Remember, 2 to the 3rd is 8, minus 1 is 7. Hey, that's prime as well. And so he probably was really excited, like, hey, I found a way to get prime numbers. And let's see, 2 to the 5th minus 1. 2 to the 5th is 32, I think. And 32 minus 1 is 31. And that's also prime. Awesome. Well, let's take a look at what 7 is. That's the next prime number. M sub 7 would be 2 to the 7th minus 1. Now I'm going to have to grab a calculator for this one. So let me do that. 2 to the 7th minus 1 is working out to be 127. And 127, I think, is prime. Certainly not divisible by 2 or 3 or 5. And I'm pretty positive it is a nice prime number. And so the first four prime numbers spit out Mercenine primes. Let's suppose we take the next prime number, 11. M sub 11 is 2 to the 11th minus 1. Now, if you're taking 2 to the 11th and subtracting 1, or 2 to any power and subtracting 1, you'll never be even. And so that's good. But this is 2047 as I plug it in. And we're finding out that it's not prime. Now think about this. It's not divisible by 2. It's not divisible by 3. It's not divisible by 5. And so now we got to check each one. Picture that happening, checking each one. And this is a big number, but not super big. When I'm talking about they use big prime numbers in order to do internet encryption, they're using like 100-digit numbers. This one's 4 digits. It does turn out that 2047 is composite. It's 23 times 89. It's the product of those two relatively big prime numbers. And so for us, if we were checking that by hand, that would be awful, right, to have to get all the way up to 23. But it does work. So that's why they're saying it's either prime or composite. They can't guarantee that it's going to be prime because some composites, like happens when we plug in 11, work out. So now what we need to do is kind of focus on what the homework's going to be like. And so the homework in this regard is going to have us just practice with Mercenine primes, finding them just like we've been doing. So that won't be too bad. There is a consequence to that. So there's an observation, not a consequence. And here's what's stated in the book, and they use it in the homework as well. They say this: if P is a prime factor of n, then, is a prime factor? Yeah, then 2 to the n minus 1 is divisible by 2 to the p minus 1. So very interesting concept here, 2 to the p minus 1. So they're obviously picking composites. So let me show you this in a small way. Remember, n's not just some arbitrary number. N is related to this Mercenine prime thing. So let's suppose I wanted n to be 6, meaning I want to find the Mercenine 6 number, meaning I want to take 2 to the 6 minus 1. Okay, what they're claiming is if you had a prime factor of 6, well, let's think about a prime factor of 6. There's 2 of them. Let me not call them n. Apologize. Let's choose one of them, but there's 2. Let's choose 3. It's saying if 3 is a prime factor of the n, then 2 to the 3rd minus 1 will go into whatever this number is. Well, 2 to the 3rd I can do. That's 8. Minus 1 is 7. So I'm expecting this number to be divisible by 7. There was nothing special about me choosing 3. I could have also chosen something like 2. And so if I chose 2, then I'm saying 2 squared minus 1. 2 squared is 4, minus 1 is 3. Then 3 should go into this number. So let's see what this number is. If I take 2 to the 6 minus 1, I get the number 63 in my calculator. Now notice what's happening. 7 goes into 63 9 times. 3 goes into 63. So if there's a prime number that goes into the n, then 2 to that prime number minus 1 will go into the Mercenine number, right? In this case, 63. You're obviously choosing n to be a composite, otherwise it wouldn't have any prime number that went into it. So let's talk about how this is going to be addressed in the homework. It's going to be addressed straight out. They're going to say, hey, if p is a factor of n, is it true that 2 to the p minus 1 will divide into evenly into n? And that may be the case. I'm sorry, you would just answer true or false. Sorry, something happened in my periphery vision that I wanted to check out. Got kids running around everywhere. So let me show you how this comes across in another way in the homework. So another way in the homework, it'll say this: find two distinct factors of m sub 39. And so keep in mind, they're not asking you to find m sub 39. They're asking you to find two numbers that go into 39. Well, you know them based upon what we just said. If you look at 39, 39 has some prime factors. One of them is 13, and another is 3. 3 times 13 is 39. So what does that mean? It means 2 to the 13th minus 1 is one of these factors that they want. And so is 2 to the 3rd minus 1. Now 2 to the 13th minus 1 is going to be a big number, 8191. And 2 to the 3rd minus 1 is, well, that's 8 minus 1, so that's 7. So those two numbers definitely go into whatever m of 39 is. I never actually have to find it. If you want to see what it is, it would be 2 to the 39th minus 1, and it's huge. That's why they're not asking you to find it. It's 5, 4, 9, 7, 5, 5, 8, 1, 3, 8, 8, 7. And if I divide that by 8191, I should get a nice whole number, and I do. And if I divide it by 7, yes, that also goes in. But this is not needed. You do not need to find this big number. You just need to understand this principle. So, for example, if they said m sub 12, well, then you know p being 2 and p being 3 would go in that. And so you know, whatever this m sub 12 number is, you know 2 squared minus 1 and 2 to the 3rd minus 1 will absolutely go into that m12 number. Or, namely, 3 and 7 will go into that number. So, pretty exciting. As we look at this. So it's just playing around with those Mercenine primes. There's only 10 homework questions in this section, and so it should go pretty quick, but let me know if there's something that wasn't quite described right through this video lecture, and I'll look to amend it. Thanks.